So let's continue with John and Håkan, two friends and ex-colleagues, by the way, who are going to present a real-world experience in introducing clojure in the city of London. Fuzzy enough?
It's a bit of a massacre.
Yeah. So, up to you guys.
Okay, so just before Christmas, I thought we almost had clojure in there. I thought we were ready. I thought the groundwork was laid. It's like I could go back and rest and actually take it easy over Christmas. But I, stupid enough, had like one final meeting just before going off to Sweden. And I was like totally unprepared, planning to chill in the REPL just to show some stuff I've been doing, and basically like, this is what I'm going to do next year. I was like, ended up like in a total horrendous discussion on static versus dynamic typing. I was like almost started crying, walking out, kind of, yeah, going back to Sweden, calling up John, and basically like, this is it, I'm not coming back next year. That's how it started. So it was kind of a total massacre in more than one way when it started.
Yeah. I think I'm partly responsible for that, because my kind of strategy to get the team and the wider team to maybe accept the idea of clojure at the bank was to grill you quite hard, right?
I know.
wanted to sort of tackle you aggressively and say, look, we're not a bad team, we're not doing totally bad stuff in this Java monolith. Are you definitely sure it's the right thing? And I think we gave you a bit of a grilling.
Yeah, and I can, from my point of view, say that I potentially, occasionally gave you a bit of a hard time about what you guys currently were doing, both how I had to kind of polarize myself, take a very hard stance, like we need to do this, and become a bit of a kind of a fundamentalist almost, until it actually was happening. Yep. Mm. So, reducing the middle office. Well.
So, yeah. So this is what I talked about, so should we just go on to the next slide?
Yeah, I was just planning to say that we are here as associates for equal experts, and you can see which bank we're working on down there. Yeah.
Okay, so I think just a bit of background before we sort of launch into how clojure really helped us. Just talk briefly about our system. So we look after the lifecycle management of derivative trades. So when a trade comes in, various things have to happen. We have to book it to various downstream systems. And then when the trade expires, we have to book it again to downstream systems. We have to close out the position. There's various calculations we have to make. And there's lots of complicated stuff that happens in the middle that can happen to a trade. A client might decide they want to do a secondary trade on a trade to up their position, etc. So our system lives in the middle office, and it's fair to say that it's just continuously doing lots and lots of things. It's accepting lots and lots of new bits of data coming from the upstream. We're doing various things to that data. So because of the fact it's in the middle office and lots of the business flows go through it, it's become a bit of a destination place. If you're a BA at the bank and you just want to tackle on some automated processing to happen to a trade at a particular time, then our system is the perfect place to do that. The downside is that, rather unchecked, it's just grown massively. So it's become a bit of a big beast, a big monolith. So it's 1 million lines of Java, so 6 years old, talks to 30 systems, although I'm pretty sure if you graphed it out, you'd probably find it talks to a lot more.
Yeah, no one may actually know exactly how many systems. Okay, so I joined this team 1 year back, roughly. And we are 40 people in 5 different countries, and because this is Euroclojure, right, like let's focus on the European contingent of this. So we are like, well, British, Swedish, Polish, Nigerian, South African, I'm forgetting something.
We've had some Australians in there.
Australia, lots of different people from other countries as well. Ukrainian, yes, in Europe. So plenty of experienced Java developers have come and gone in this project. Like lots of good work has gone into this, but it's kind of been done as an incremental way, and lots of people come and go, add their thing, lots of kind of, well, how should I put it? People have their own favorite pieces they have built in the system, which has kind of grown in different parts of it, and no one really understands the full piece of it. But on the positive side, we have quite high degree of flexibility. I would say like this is actually one of the, not the best, maybe hard, but like it's a very well-run XP project in one level, which also makes it very hard to come in and try to kind of switch it up a bit, because if a project is kind of almost totally messed up, right, then you can come in and like you bring out the XP book and say like, okay, we're going to do this, and then we're going to do that, and you kind of, people are busy for a while. But in this case, like you kind of had to come up with something new to actually switch it up a bit, because like, yeah, it wasn't simple.
So let's talk about the monolith a bit more. So this system has to stay alive. It's it's not an option just to draw a line in the sand and say, look, it's a big ball of mud. We want to spend a year just breaking it apart. We want to rewrite it. We can't do that. It has to stay alive. It can't go into gardening mode. It can't go into a maintenance mode, because our system is where stuff happens, and the business have a long backlog of things they want to add to our system. But interestingly, I think it started off as just a single system. It's like a middle office system. Stuff comes in, and stuff goes out, and stuff happens in the middle. It's not rocket science. But at some point, it moved from being a system to more of a platform. And no one really recorded that moment. One day suddenly it was mission critical. We've onboarded these new flows and they go out all across Europe, and suddenly everyone demands that our application is up the whole time. And people want to come and build some satellite services on the side of it. So we've now gone to this more platform model. We've got some services, but certainly until you joined, and I think we hadn't really spent the time to think, how can we build these services in a proper, lightweight way that we can be a bit more responsive to the needs of the business?
Yeah, one obvious problem, right, because it's so big, it takes quite a while to actually understand how you could potentially try to change it even. So it's not like anyone who rocks up to this project will obviously sit around for a while. Like I definitely did it for at least 6 months before I tried to do any serious change in any way or form, before I started kind of promoting clojure relatively hard, because I felt like what we're up against here is basically we cannot do it using these tools. Like we have very good Java developers moving large chunks of Java around, like in IntelliJ, and it's like, yeah, been there, done that, right? Like we need to bring on something else. We need to try something else. That was at least my theory. This theory obviously wasn't necessarily shared by everyone from day one.
Yeah, I mean that's really the nub of the debate. Do we incrementally just chip away? And we're quite good at that. I think that we've got a fairly good team, very experienced Java devs, and we could just chip away continuously, or do we try some things radically different? And at that point, I as high the Swedish guys come in and be that radical change agent.
Yeah, and I said I almost gave up, right? Like it's very close, because it's not easy to do this kind of, like you're trying to, you force kind of a change on people who may not want this change, right? And you think like, yeah, you actually really want this change, but it's hard to kind of sell that when you're trying to kind of push it day in and day in. And after a while, I got tired of myself after a while, like keeping promoting stuff, and I was like, no, this is not really this battle I'm going to fight. Like there are many things you can do in life, and this is not the kind of battle I try. So I said I almost gave up, but John kind of pulled me back from the brink of giving up. Okay, so what is the problem we're actually using clojure for?
Sure, so we didn't want to just say we're going to rewrite the entire system in clojure, but we did want to introduce clojure. So we've got this area of our system where our system's a pretty big beast. It's a monolith, and we've said that. But there's an even bigger beast, there's an even bigger monolith that sits in the back office. And our system has to talk to this all the time. It has to book trades into this system. I'm not dissing this back office system. It's just grown its legacy. There's a whole suite of DBAs which are trying to put life into this thing. It's very good at what it does, but it's very difficult to work with. That's probably one of the main reasons why our system grew into existence, was to make life dealing with this back office system a lot easier.
Yeah, you could almost say like our system is like 1 million lines of Java to basically script this other system and a few other systems. So to talk to the system, there was definitely when you joined and when I still joined, there was this text-based DSL rule engine in place, which kind of was meant for the business user to be able to update the feed. So basically, I don't know how many levels we're going to do deep into actually detail it, but basically this is how we feed. So the feeds we feed are like big JSON blobs around between 100 and thousands of fields in a big JSON thing we feed down to this other backend system. And the rules aren't arbitrary, right? But for me, who doesn't know much about finance, they are relatively they are complex rules. So the idea is basically we have this text-based thing which the business user will be able to actually edit and change. There's even code in our system, or in the big system, that actually reloads these and the text changes. So there was obviously a very good thinking around this, and there's a dream about how this would work. In the end of the day, the way it really works is when you say it's 100K lines of code, it's a mix of text and Java, weaving in and out of each other, copied and pasted in the text piece, right? So it's quite hard to follow what's going on in this piece of code.
I mean, it's a nice idea that the business can come in and understand these feed text rule files of how to book things into a downstream system. But the reality is they don't care, right? And they'll just ask us to copy and paste. We've just ended up with 50,000 lines of it, 50,000 lines of Java supporting it. So it's a bit of a mess. It's a good idea. but it wasn't.
Yeah, well, they obviously do care very much when things go wrong, right? And then basically you have to sit around and try to figure out what happened in this. Like when it's similar to like, we'll come back to that later in our fit test, right? Like when you try to build this artifact, they're supposed to be owned by someone else than actual developers. And you try to build up slightly different ways of working, but when they stop using it, the way it's kind of, the dream is intended to work, then basically you're stuck with this kind of big text piece, right? Yeah.
So I mean, the last point is obvious. It's this layer in between the two big beasts in this bank. It's a big waste area. It's like a perpetual motion machine of JIRA bugs that get raised against it. And the business tries to get in there and understand it, the devs try to get in there and understand it, but no one really understands it comprehensively. It's a very difficult area to work with. It's a huge amount of waste for us.
Yeah. Okay, so why did we choose clojure? So I guess in a way this is kind of like, this slide is almost wasted on this crowd, like because people have probably bought into this already, right? But just to give you an example, like because it's basically, the first problem with shoes, while a very important problem, is simple in the sense like, it's actually just a feed. Like we're trying to figure out, like we basically have two large maps coming in and we produce one other large map coming out. Like that's our entire clojure piece. But it's quite like, it's not simple just because of that. And we hope that by introducing clojure in its place where basically, well, it was simple and functional, like it's just basically the facade for this thing, as I said, it's just a simple function. Then we don't need to think about all the other things and we can basically just get it in there and basically establish a beachhead so you can start keep moving clojure into more pieces and chucking away at this big thing and basically pulling more and more things out and putting it in clojure. So, and again, like, I guess this is really your point, but it's a real test, right? Yeah.
Yeah, I mean, it's quite simple in what this layer does, like stuff goes in and stuff goes out, but there's lots of complexity in the middle, there's lots of rules there. And this is a big waste area in our project. So if we can conquer this waste area and make the business happy, and then everyone's happy, then we've proved clojure, and then we can take it from here and take it further into the system and the bank in general.
Yeah, and then, so actually one of the ideas when they originally rolled out the strategy was basically like, so John was already interested, like everyone was interested in doing something about this area, and then basically, for a long time I didn't dare to mention clojure. I was kind of suggesting different ways to attack this, but eventually I was like blurted out, like let's just use clojure for this, like it's obvious, like they already have like a big text-based DSL, you cannot buy a book on that DSL anyway, right? Like, so they cannot really use the, like, we don't want another language retort. So, and also, like, instead of kind of sitting around and trying to build, like, some kind of small scripts on the side with clojure, like, let's go in and tackle our, like, our biggest feed, because if we manage to do that, we basically we put everything on one, what do you call it? One bet, whatever you want to call it. Oh, okay, so the approach.
So, as I said before, we're not labeling this a big bang rewrite. In clojure. Interestingly, at the bank, there was a different team, and they took this approach. They said, we're going to rewrite our system in Scala, and we're going to go ahead and do it, and it's going to be awesome. But then what happened is the business didn't quite see the value for that. A couple of guys that came up with the idea left, so it got killed halfway. So we were quite conscious not to announce to the business that we want to take 4 or 5 guys for 6 months and onwards to work on a clojure rewrite piece. We very much branded it as, you've got this huge waste area, we think, and we're going to solve it for you. And the clojure thing is just an implementation thing that they don't really have to know about as a primary conscious thing.
Yeah, and an important point here, so we can have a parallel effort because where we have some of these very good Java devs actually sitting around splitting the current application in part. So our application, while it's very big, it's actually just one big web app where everything has become stuck into over time, right? So it's like a 1 million line web app in a 32-bit VM. And basically they want to kind of separate the back end of that, the actual processing logic, which like basically should never go down, right? Because that's how the trades flow through from the actual front end where people click around and see things like the actual users. So we have that parallel effort, and the idea is that we're going to meet somewhere down the road. So like once they have started tearing this apart, we should have been able to prove that we can actually use clojure for one of the pieces, like the feed, which is relatively functional in nature, and maybe able to say, okay, why not start doing some of the actual lifecycle management, or actually some of the onboarding of the financial products using some kind of clojure piece, right? Okay, so this is actually my slide. What we did, so we actually, the first thing, and I didn't really do this because I understood what this would lead to, but I raised my hand stupidly in a stand-up very early on and said, like, okay, I can look at this search piece, and then I got sucked in for like a 3-month thing introducing Elasticsearch. But that actually proved very useful later because our data layer, basically our system is fundamentally wants to use a document database, but for some reason, potentially politically, right, like they can't, so they have like everything is stored in Oracle. It's very hard to get to your data or query your data. Like, so you kind of almost like at arm's length from it, and not only from arm's length from it from the fact that it's an Oracle in a big club, right, because they actually store down basically the XML, right? So we have like Hibernate on top of that, right? And then we have like Podios on top of that. So it's like to add a field or do anything, like to do anything to your data, you need to basically go through this insurmountable piece between yourself and the data you actually want to touch. So a bit sneakily, basically, like, okay, you need a new search engine. Let's introduce Elasticsearch. So Elasticsearch is basically, it's a Lucene-backed NoSQL store, you could say. Like it poses as a search engine, but you can actually use it as your primary store. And that's one of my, like, I kind of want to push for that, but the team is not buying that yet.
Well, I think it's pretty awesome. I think, so we've got this page on our wiki which is useful SQL, and there's a list of SQL statements which is, if you need to access the data and do queries on it about the volatility of the market and various other things, then you can go to this useful SQL page and it'll show you how to access that database and get these stats out. And now we've got a useful clojure page where you can just rock on and hit Elasticsearch and pull out the JSON and do queries. And it's so much more powerful. Yeah,
this is actually a bit of a tangent from this slide, but it's been proven very, very useful. Like when you do like run the bank things and actually want to kind of just figure out what happened, you can use clojure now and actually query this data store and then quickly come back with some kind of ad hoc CSV file that like potentially could have taken a very long time to produce otherwise. So the kind of the marry of these two is very, very beautiful actually. So when we say clojure to free our logic, right, we don't mean like, so this classic Java system, like it's in one way, when I first joined, it took me like long time to kind of get a feel of this because it's like, it's very, very well written, but it's also very like Java and lots of layers, right? So it takes a while before you understand where's the if statement I'm actually looking for. Like where is it? Like you dig around in like IntelliJ forever and eventually you find an if statement that actually does what you want to do. So basically what we're trying to do, or maybe you want to mention the position, well, this position counting thing, right?
Yeah, so we've written some new code in ClojureLand, which is to tally up the positions of the various trades that we've got that a particular customer might have initiated. And if you go back to our old app, this position counting thing is like a mini fiefdom, it's like a mini empire. It's like you go into Springland and then that's got like strings that point to a Java class, you go there, the class is an interface and you just dig down, it's like, what the hell's going on? It's, you know, it's really hard to understand. And then in ClojureLand, it's just like 20 lines or something, maybe 30.
Yeah, depending on half of it is surrounding. So basically what we did in the end to power our actual feed, so we build our own little tag-based rule engine. And usually when someone says like, okay, you build your rule engine, then it's like, okay, that's a stupid thing to do potentially. But because it's not very big, and when I say 10K lines of code, that's not actually the rule engine. The rule engine is maybe less than 1K line of code, right? The rest is like, we have other stuff in Clojure as well, including actual rules, right, which are maybe like 4,000 or 3,000 lines of code. So actually in theory we could have like lots of slides explaining how this in detail works, but it's not actually very complicated. But it took a very long time for us to understand what to do, because the rules are very, like if you try to model it, and it's all been done, right? If you try to model it using normal object orientation, there's so many side corner cases, so you get all these traits and interfaces coming, weaving in and out of each other. It's almost like I tried to sit down, like, now I'm going to learn object orientation, right? Like I'm going to try to model this problem in like Java, and I couldn't figure it out. So next year maybe. Okay, timeline. So we started just before Christmas, as I introduced this talk with. So while it was a bit dire, right? People actually were quite on board. So that's why when I went into that final meeting thinking that this is solved, like we're done, like after Christmas you're gonna, was like, this is the problem, right? You're trying to push for closure, and you're trying to actually, you want to use this to solve a real problem. You don't want to argue about which language you're going to use forever, right? That can tire you down very quickly. So like, I just want to get to the heart of the problem, because this is a very, very complicated problem, right? And potentially big, like once we go through the first part of it. So basically people got on board, they started ordering like all the kind of joy of closure, structure implementations and stuff like that. Like, and basically we're quite excited. Like that's why I thought I was safe for this final talk. And Pither, who sits around there, he actually came back after Christmas and wrote the first version of the rule engine, right? And John kind of called me when I was Sweden, dude, like it's on, it's actually happening. And I was like, okay, I'm coming back to London. Okay, so how do we do this? So as I mentioned, we have a huge Java app, right? Huge, which runs inside Tomcat. So this is a bit unconventional approach. So we actually have an OSGI container running inside, like as its Spring Bean, where we deploy our clojure application inside. I'm not very happy with that approach, but what the good thing about it is that it actually solves an immediate problem that we don't have to always like sync up with like which old version of like Spring or whatever, not that we use Spring in a new thing, but like some random commons logging thing that we don't have to think about that. So basically we have like a little clojure thing sitting inside OSGI. It's not that small anymore actually, because we pull in all these kind of jars. So we build an Uber jar, deploy it as a bundle, put it inside the real big app. So we have two approaches basically. Well, we also have a Noir app running outside, which is the same bundle. So we build one jar in our build, so which both acts as an OSGI bundle and as a Uber jar which runs Noir, which has reporting, and they kind of coordinate and basically kind of corner this big, like one is from the inside and one is from the outside. That's kind of how the idea, how this is going to work. But we kind of want to get rid of this OSGI piece as soon as possible because it works, but there are some horrendous class loading issues in this area. And yeah, the reconciliation app.
Yeah, so we built the mapping layer using a new rule engine, which is pretty cool. We also built a reconciliation tool as well, and we built this as a Noir app too. So our users could come on and they could rec against the two systems, and we had quite a lot of fun here. We got in there and we got to rec a huge amount of data, so we looked at all of the things that Clojure's got to offer in the concurrency space. And we ended up with something quite good. We had some keys in there, some futures, and some agents and all that stuff. We almost did a tour de force of what's there, and we used it. And what really impressed me was it's just so easy, just working with message queues and concurrency and Clojure. You just throw a function that you partially built up with some data onto the queue, the thread just picks it up and then just executes that function. And it's all done in just a few lines. Like this whole piece is just mammoth in our existing app, but in the new app, it's not so big, it's quite straightforward.
Yeah, and this is very interesting actually because when I kind of was so focused just getting Clojure in this, I was thinking about this little interface which took two maps. But then once the dam broke, right, people just started building all kinds of stuff around it, and the turnaround time is it's very interesting, right, to see the kind of tools people quickly throw up, right, like in an afternoon, like, okay, look at this thing, and it's like, oh, that's interesting, right, so, like, and that's obviously was the real goal, like, that's what I kind of dreamt about that we eventually will reach, but I was kind of, people really relished, like, just getting in there and starting coding.
It's kind of interesting.
Good times, yeah.
I had a conversation with the people at the bank on Friday, and it's gone from why are you guys rewriting this area to wow, you guys are producing this, you've got this new app and we want it now, can we have it next week? Can we have some more?
Yeah. It's fun. Okay, testing.
So in our existing app, we've got like 5,000 fit tests, and I trust that most people know what fit is. It's always kind of specifying what you want to test in an HTML form. It suffers from the same problem as the layer that we're replacing, and the fact it's a DSL. It was meant for the business to be able to come in and see the tests and to help write them, but in reality, they just went on a copy and paste mission, and overnight we've got like 5,000 of them, and they take ages to run. So we're pretty sure that we don't want to reproduce that. That's a bit messy. But the nice thing about the fit test is the output. It's nice to have that report of what worked and what didn't. We like that. So we kept that side of it. So we recorded all of the data that actually goes through the system using the fit tests. We then froze that data down, and we built some lightweight infrastructure that pumps that data through the new layer and then generates these nice HTML reports on the outside. And if one of those reports fails, one of those tests fails, and you can see it in Team City, you've got all the reports there. So it's kind of nice.
Yeah, that actually worked out quite well. And we hope people talk about event sourcing. Our system is fundamentally kind of relatively event source. Like you get different events in lots of stuff happening. We have this long list of events. So what we want to do eventually is be able to pull out that entire list, what happened to like all the trades that happened to a specific product, like and whatever, and freeze all that down and basically be able to use those kind of similar approach to hook in. Like, okay, books, we basically record all this stuff in a real system, right? Which just pumps through things like for real, right? Like real. So it's not like any kind of mock strange data. So like actually that's what John said, actually, yes, we're using our fit test, but we're also recording data from the real system and uses that as test, right? Without going into like a anti-mock rant, but like we're trying to keep like the unit testing at a minimum in this project. Like that's one of my ideas when I first like let's not test almost anything until it breaks, right? And I guess like we have to test this because it's like kind of an acceptance test. We need to produce this JSON, but like we don't understand like. It's very interesting to hear that around like the namespaces in the talk earlier, right? Like we don't understand how to structure. Still don't really understand how to structure a clojure app. It's basically just a bunch of namespaces in a directory. So it's like, let's not overdo this. Like, let's not try to kind of use like anything we don't understand yet. And because people come in and basically rewrite like half a namespace like in a day, right? And it's like, okay, it's just gone. So we kind of trying to rediscover, but actually people did rediscover the value of unit testing a little bit.
I think there's a downside to well, I think it's the right thing to do. The slight downside is that we didn't have many comments, we didn't have many tests. So if you want to understand what the heck a function does.
Yeah, this is actually a very interesting point, which may or may not have anything to do with units, right? When you pass all these maps and stuff around, it's like, sometimes you write the function and think like, this is cool, and it's like 2 days later someone comes to this function, it's like no one knows how to actually call it. Like, you sit in your fun REPL and you can do stuff, but you have no idea how to call these things, right? So that's kind of a little bit of a problem. I still don't know really how to fundamentally solve that. So people started using a bit of preconditions, started writing a little bit more unit tests. My personal approach, or not approach, more than my what I would like to see is just remove as much code as possible. I think instead of kind of like start there.
I guess we're in a compromise right now where the kernel of the rule engine of our new app has lots of unit tests around it, but then the rest, like the satellite stuff around the side, probably don't test that well.
Yeah, including this Noir app, for example. So one thing we really want to do, because we had this problem by navigating around in IntelliJ and in our text files, we want from the start almost building like kind of an introspective app on top of our rules, right? So you can basically go in and easily query, like what, if this field comes in for an instrument of these, like with these properties of this currency, like what will happen to it? So you can actually see how that fires. So that was something we wanted from day one. And we first built that, and then eventually built that kind of entire reconciliation piece on top of this. So, yeah.
I think like one interesting thing is that everyone says that code is data, and you know we've learnt from that, and we can introspect our code, and we've got a web app around it where you can see what's going on. Ish, you know, we still need to advance.
Yeah, there's lots of like. No, we'll get to that. Like, it's not like we're done, right?
But I think the interesting thing is our tests. That they are data too. So having like a web app that's dedicated to browsing around the tests, they've been able to filter them, been able to kick them off from this browser. It's quite a nice way. It's almost like decomplecting what is there in Fit, where you've got the presentation and the test combined. We've just got our tests, which are raw JSON, and then we've built a framework and app around it, so you can actually see what the test is about.
Yeah. No, it's actually, that's one of the, well, we're not there yet in the end, but like maybe one of the most interesting pieces like was this actually, and I think it's worked out quite well. Yeah, so, but we're not done yet, right? We're kind of still doing this. And when we actually proposed this talk, we weren't sure if it's going to be like, you know, a kind of horrific post-mortem around how we failed, but at least that potentially would have been interesting as well.
It still might be.
You know? Yeah, that's true. Yeah. But we have had clojure in production since March at the bank. And we have a long-running debate now around what works, what needs to change, how do we keep going with this. But the fun part of this, like now we don't sit around in a room and beat each other up around static versus dynamic typing. Like people have seen that this actually does work, and it's relatively constructive debate, like even if it can become very harsh sometimes.
Yeah, like we still argue a fair bit about do we rewrite what we've got, because we don't really like the rule engine. You know, we've been through that cycle of we've got something out there, it works, but we want to make it better. And it's kind of like timing. It's like, when do we do that? But
yeah.
The nice thing about clojure is that everything is data, so we could potentially suck in all of our rules and then spew out something better.
Yeah. No, there's been spiking in that area. Okay. So this is like one of my things, right? Like, so yes, clojure is a great language, it's cool, but the first question you always get, like, and like some very well-experienced Java developers push back on, right? And it's like what can you do? Like, and this question is obviously like, it's impossible to answer. Like, yeah, you can do anything, right? Like in theory, which is different. But it's like, for me, it's about like just switching the cultural context. Like instead of sitting like in, like where everything, like stories come in, we build stuff, we run some fit tests, we sit around in Java and just do stuff. More coming back to more like creative approach to software development. So that's what I kind of like. So basically people ask like, is Emacs really necessary? Like people start getting like, okay, I get, okay, clojure could be fun, but like like this final pushback. I was like, no, it is actually. You need to use Emacs, not because you really need to, of course, but just because you need to kind of fool yourself that you're doing something different, right? So basically, no. It's true, right? Because if you sit around and people are like, no offense to like clojure, right? It's like great IntelliJ plugin, right? But then it's like you quickly back in there and it's like, okay, maybe I don't really understand how to model this thing, because that's something we really still struggle with, right? Like some of the things are very easy and we're very happy with, like, yeah, it's not that much code, but some other stuff is like, I don't really know how to scale it, like, and to actually, like, so it's kind of like, I think we're almost reaching a point where we're starting relearning some of the object orientation skills we once thought we had. Okay, and I think this actually went, by just stay on this slide for a little bit, I think while I got lots of pushback on this initially, I think it actually worked out relatively well, because people, like, they got into like the Emacs workflow, sitting in the REPL, doing stuff, like just getting out of, like just having fresh air and not being IntelliJ, like with a huge system which is like indexing like half of the day, right? Like it's quite cool actually. Yes, the future.
So the future is, by the end of this year, we want to have clojure inside the actual app, inside the lifecycle management piece. We're considering trying to circle the enemy, take over our testing infrastructure with clojure. We like this test browser that we've got, we like that approach, so we might try and tackle our system that way, and then at the same time go through the middle. It's deployed there anyway with OSGI. So by the end of this year, we want to have it inside and then outside, slowly choking it off.
Yeah. And as we said, there's another team, or like not really a few other guys in our team, more like the more conservative Java guys, like they are strongly pulling the current app apart. So at least then we will have two apps. So we have kind of, and then we pull in clojure from different angles, right? It's going to be interesting. So they're basically, and this is just taken straight out of nowhere, right? Like I have no idea if this is true or not, but with constant hacking and relentless energy, we could maybe actually have the majority of this app in clojure in 2014, right? Because I think once the dominoes start falling, they will just, as we see, like for example, it's like when you start pulling out so many kind of things, they shrink so quickly, and people start forgetting. It's like, and plus people sit around like, how are we going to model this thing? Like, how many different objects do I need to actually create? It's like none. Okay, are we done?
As usual, while Zach comes up, you can get questions.
Okay.
How much time have we got for questions? Is that much?
While we wait for the next speaker to sit down.
Okay, sorry. Yep.
How many people do you have working on clojure right now? How to select which people to retrain?
Okay, so the question is, how many people are working in clojure? So our London team is around 10 people. And I would say around half of that team is constantly in Emacs. And the training aspect is actually very interesting, because I thought like when we introduced this thing and people started ordering the list books, it's like, you're going to sit around and talk about what is reduced, what is mapped, like forever. But no, people just picked it up and started running with it. It was quite cool. Like, so that was not a problem. There's no training, like on the job, basically from day one, delivering.
So we actually called it this clojure pod. So we've got our team, we had this sort of pod inside our team. But the idea was that anyone could come in and enter that pod if you wanted to. Kind of served itself. We didn't need to say who's in and out. People just naturally gravitated towards it, the people that wanted to do it.
So it's not that you just take a team and say, all of you are going to
No.
Yeah, it's like we've got this pod, it's going on, and it needs 3 or 4 people inside it. But if you want to come in, then come and just join. And that was quite nice, because in a way there were some people that sit on the sidelines a bit and they didn't want to join straight away. But then once they saw it running, it's like they thought, yeah, I'm going to join it now. It's like some guys doing it, I can pair with them, I can learn off them. So it kind of served the guys that wanted to get in and push it from the get-go, and the people that wanted to join it at a later stage.
Yes.
Did you collect any empirical statistics about code production
In terms of code production, I mean, our clojure app itself is what, like 10,000 lines in its entirety?
10,000 lines of code, but that includes the rules and includes the actual Noir app as well.
Yes. So the mapping layer, we calculate it's going to be an order of magnitude less than what was there in Java land. I secretly hoped for two orders of magnitude. I think it will be closer to that. So we've got like a kind of eye on the running total.
Okay, Jen? Well, I hope someone in 6 years' time is going to, well, so the question is like, what's people going to think about it in 6 years' time? And I hope they're going to think it's quite crap. I want to rewrite it again, basically. I don't expect it to survive.
Okay.
Okay.
Thanks all again,
Thank you.
guys.